Hey everybody, welcome to the NVIDIA Omniverse live stream. Super excited to be with you today. We have some very special guests, as you can see, straight below me. We're going to dive into industrial design with OpenUSD and generative AI. And because of that, we have probably one of the most expert companies joining us, Siemens, in this area. And anyone who attended GTC physically or even virtually, you probably got a lot of news about what we showed off there from some of the great work from the Siemens team there. Richard, my colleague right below me, he actually was one of the NVIDIA devs that was showing it off if you saw it at the GTC floor. So we're going to dive into that in a few minutes. But we wanted to start off by letting everybody know that the announcements at GTC are now being fully absorbed by the community. By first, we have playlists that have been created of the GTC sessions. So if you missed GTC or you were there and you want to catch a session either again or you want to watch it for the first time, they're now available via NVIDIA On Demand. And Amelia's posting the link right now. Thanks, Amelia, on the screen, also in the chat. We also have several playlists along related to GTC sessions for different folks. So we have OpenUSD sessions, OpenUSD Day sessions rather, which was an amazing experience, a whole day revolving around OpenUSD development. We had an OpenUSD luncheon, which obviously is not a playlist session there, but if you were there, you got to have some break some bread with some other developers in the community and NVIDIA devs. But all the sessions that were part of that day are now available there. We also had the OpenUSD training sessions, which was incredibly valuable. I heard from many people while I was at GTC how helpful and formative those training sessions were. So that link is there also in the chat and on the screen. And I think there's one more playlist, if I saw correctly, that we created. I'll let Amelia put it on the screen in a second. I think it was, I think there's a general playlist for just NVIDIA Omniverse at GTC 2024. So all those sessions are available on demand. And we hope that anyone who wants to kind of engage with the community on these sessions, you can jump over to the forums if you have a question, a technical issue, and if you want to chat with other folks, come to the Discord server, NVIDIA, which is discord.gg/NVIDIA Omniverse. We have a channel for GTC, which is still there, but also all the other channels based on the various topics, including Isaac Sim if you're doing robotics work. So it's very easy to navigate. And we saw a nice, this is one of the amazing things to happen at GTC where, obviously Omniverse was a big part of the GTC and most importantly, OpenUSD. And a lot of people have come onto the Discord server in the last 4 weeks or so as a result. So I want to welcome all those new users in the community. It's great to see so many new faces. And I want to give a big thank you to everyone in the community who's actually been helping all those new users. I've seen so many great conversations and connections, assisting people who are just learning about OpenUSD for the first time and working with Omniverse and other great tools in the ecosystem and need a little helping hand. So Discord is a great place to go for that. I hope that everybody can join there. And then we also have just announced, speaking of OpenUSD, our OpenUSD challenge. So we would love to see what your projects are with OpenUSD. And if it's the first time you're doing it, even better. And I think people will be blown away at how easy it is and how many doors open up by leveraging OpenUSD in your workflow. So we have a great forum post. If you click on that link in the chat or on the screen, you'll see a great forum post that goes over the challenge. We basically just want you to share your work on social media. If you want to share work in progress and get some feedback, we have a community challenge channel in the Omniverse Discord server. It would be great. We've already actually seen a couple of great posts there, even though this was just announced a few days ago. But as you'll find out also from our discussion today, OpenUSD is transformative. And we're really excited to kind of shout it from the rooftop and let people dive in and learn it. And we're here to help you along every step of the way. So I want to, okay, so with that being said, we have an amazing topic here today. Most people will probably be very familiar with the Siemens name, but even if you're not, we're going to go into that right now. So let's start by introducing everybody. So Richard, why don't you give everybody a little refresher?
Yeah, I am the Omniverse forum manager. I help people on the forums and a little bit on Discord and just try to use my knowledge to facilitate people working in Omniverse, be it in our apps or in installation. And I was on last week when you weren't here, Edmar. So
You did a great job. I actually watched that. That was an amazing So I'm glad you brought that up. So if anyone wants to watch a nice recap of GTC, last week's live stream was fantastic. It's on YouTube right now. We'll post a link in the chat. But we went over configurators and Paul Cutzinger and Ashley and Mario and Eric and Richard. Really, really fantastic show. So be sure to check that out as well. And right next to you is a great member of the community who I actually met in person at GTC, Scott Dempsey. Nice to see you, Scott.
Always lovely to see you, Inmar.
Calling in from Scotland, and as you can see right now, he's on land, which is relatively rare. He's usually out at sea for months at a time. So why don't you tell everybody a little bit about your background?
Yeah, so my background is was industrial automation, and then that kind of led me into offshore, and then using a lot of Siemens technology and similar technology to operate, different types of robots for, installing subsea cables, whether it's telecoms, oil and gas, or power cables. So that's sort of a little bit about my background, but I've been involved in AI and Omniverse and Isaac Sim, so I've sort of fell into Edmar's sphere of influence, and then so it's good to see Siemens and NVIDIA working together. And this is going to be a great thing going forward.
Oh, well, I'm really happy you're able to join us today. And right below you is Shashi on the NVIDIA team. Shashi, how are you doing? Thank you for coming.
Yeah, great to join. Thanks for having me over here.
Yeah, well, our pleasure. And you've actually been working with the Siemens team for quite some time. You want to tell everybody about your role at NVIDIA and how you've been working with Siemens?
Yeah, so my role at NVIDIA is to really help with our independent software vendors and other developers connect with NVIDIA technology. Primarily, what I do is I work with our partners like Siemens and Ian and look at how they're trying to build out their solution and look at what things we can do to help them and enable them to basically go to market and build out their solutions with the enabling technologies like Omniverse or NVIDIA AI or other platforms like Jetsons and so forth.
That's awesome. I'm really glad you're able to make it today. This is going to be a great conversation the whole way through. Last but definitely not least, a guest of honor, Ian Fisher from Siemens. Thank you so much for coming today. There was so much excitement about what we showed off with Siemens at GTC. And really, really happy you're able to make it today. I think we have you for about a half hour, so we're going to try to move quickly. But let us know kind of your background and what your role is at Siemens.
Yeah, hello everybody. I mean, great to be on. Thank you for the invite. Yes, Ian Fisher, and based out here in Costa Mesa in Southern California. Been with Siemens now for 29 years, I think, in the digital industries group, and in specifically software, where we are actually looking at the software industry for everything from design, CAD, manufacturing, simulation, data management, everything, all the sort of software that helps manage the life cycle of products going from concept, design, planning, manufacturing, all the way through to operation. Really that sort of software element of what digital industries is. That's kind of where I've been going, where I've been working, specifically in visualization. I'm a technical fellow for Siemens in visualization, and now we're really looking at taking it up another notch. We're an industrial company, one of the industrial companies, and we want to take the lead in industrial metaverse, and that industrial metaverse is obviously got this really big visualization element on it, and we really want to actually working with NVIDIA in all the great technology that they have. That's what we want to actually bring to bear in this world here now. So that's really what my role is how do we bring this into the industrial metaverse, right? Yeah.
That's awesome. And I have your website open on the screen. I think Amelia just posted in the chat as well. So this is where you can go to find out kind of the team that Ian works on. As you just mentioned, Siemens Digital Industry Software. And can you tell us a little bit about, let's start there actually. So tell us a little about like kind of Siemens background as a company and the focus now and a little bit more about the Siemens Accelerator.
Yes, no. So Siemens obviously is an industrial company. Everybody knows. Obviously, they know it for energy production, healthiness, for medical devices, and so on. But we also do the technology of manufacturing, whether it's as I say, software We have factory automation, process automation, everything to do with manufacturing, whether it's production line, the actual equipment that goes on the production line and assembly lines, the actual controllers that you find, the logic controllers, all these sorts of things, all the sort of industrial equipment. We do that. We also do the software that goes with it. So really, Siemens is a big part of the actual manufacturing sort of revolution that's kind of going on, and that means going technology, software technology that's going from everything from concept all the way through to operations. They really have a role to play in all of that, and so they feel best positioned, one of the best positioned companies to define and lead in what's going on with the industrial metaverse, definition of digital twin as we go forward, all these sorts of concepts as we go forward. And so, really, Siemens is not shy about the fact that, hey, we are the industrial company that is in the best position to actually take industrial metaverse forward. However, this is a big proposition for us. We can't do this alone. We have to, NVIDIA's got great technology with their sort of accelerated computing platforms for graphics, for AI, for robotics, everything. This is really defining almost the operating system for these kinds of things. And so really what we want to do is layer on our industrial metaverse knowledge and our knowledge of industrial into this kind of world. And so this is why we want to partnering very closely with NVIDIA. This is an important partnership for us because there's a lot of technology that we can bring to bear in the industrial world here, because the world is expecting things to be, the digital twins to be more realistic, less errors, be cheaper, more sustainable. There's all these things that we've got to do as we go forward, so that we believe that we can play a role in all of these things, right? And so, but we need to be able to partner with people like companies like NVIDIA to actually deliver that on that vision. We can't, there's no way that we can do this on our own,
Yeah, it's amazing. I was just looking at the services, software, and products. It's really pretty comprehensive if you look at this.
Yeah, we do have a saying for it. It's only Siemens knew what Siemens knew.
Yeah,
we have so much industrial knowledge. We bring it to bear, and we're pretty open with it. And also the thing is, we actually want to bring, do good with this technology as well. This is the thing we can actually bring capabilities forward, communities forward, as we enable better manufacturing practices as we go forward as well. So we see this as a force for good.
Let me see if I can play this. This great video. We had an error a minute ago. Let me see if it works now.
Great video.
Play it over. Hopefully it plays okay. If it does play, we'll be back in 2 minutes. But this will give everybody really good background on what Siemens is doing.
Siemens technologies transform the everyday for everyone. Teamcenter X, our leading product lifecycle management software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating NVIDIA AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial scale design and manufacturing projects. Our customers, HD, market leader in sustainable ship manufacturing, builds ammonia and hydrogen powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result, an ultra-intuitive photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the same scene together. And this is just the beginning. Working with NVIDIA, we will bring accelerated computing, generative AI, and Omniverse integration across the Siemens Accelerator portfolio.
Wow. Okay.
There, he said it.
That was great. I know when something's really good when I get goosebumps, and I definitely got goosebumps.
Yep.
I've seen that a few times already. Super exciting. And in our warm up, we actually talked a little bit about accelerated computing and how Siemens is leveraging that. So can we talk a little bit about like what kind of opportunities are you guys trying to unlock with this, and what kind of users are you trying to help?
This is the thing about it. We manage a lot of data. We have an extraordinary amount of data. People in manufacturing, any industry, whether it's marine, automotive, aerospace, whatever, they have this incredible amount of data, and they're now, typically being able to see it in a sort of engineering context. And now what people have done is they've got this investment in this data, and what they need to be able to do is make it available to everybody, and everybody in the enterprise. And typically it's been either these sort of cubicle workers, if you like, sometimes we call it white collar workers, have been able to see all this data. But then actually, as you get more out into the shop floor, into the shipyards, into operations, people can get sort of 3D data into there, but it's very difficult, very expensive. And what we've got to do is lower the cost and the ease of getting data out there. Plus, also people need to be able to see the data less in the engineering sort of frame of reference. In other words, we sometimes call it the kids' crayon box kind of colors and things. They'd like to see the product, see the real product. They're looking at the real product. And if I'm seeing a virtual representation of it, they should look pretty similar. If I'm looking to do a service instruction on something, it should look like what it is you're servicing. And so sometimes people dismiss this idea of, oh, do you need photorealistic renderer or good quality rendering? We think you do need good quality rendering. Why shouldn't you have good quality rendering? So that the thing you're working on is the thing you're looking at. It should look the same, lighting models, materials, things, and that needs to be brought to everybody as much as you can. And that's what we're looking for, is how to bring this together in context, but also connected to the engineering space. This is where the cost comes in, cost of management of that data and cost of delivery, and just the availability of that technology to see this thing in real life and experience it. When you see it, it's much more engaged. I'm pretty sure I heard it from Scott a little bit beforehand, before this call started. Really, the fact is that people can visualize things easily, accurately. You can save a lot of time and money by doing that. And it's amazing how just having that easy access to real visualization, really accurately visualize things, it's a huge time and cost saver.
Absolutely. Wow, it's powerful. And Scott, what do you think, Scott? You agree?
Yeah, I mean, definitely. That's something that we spoke about before we came live. Recently I was on a job with an unnamed company, and they went into a shipyard and they were building the ship back up, and they put one of the parts on. This part maybe was like 20 tons, and they put it on backwards. And it was, had they had a very photorealistic digital model of this framework that they were supposed to put on, then they would have noticed that it was upside down. Now that probably cost like $200,000, and for the difference of just not having a digital model, that you could have handed over at the shipyard on an iPad or whatever, and says, right, look, here's what you're building. There it is, nice 3D model. You can look around it, perfect, really, really easy to do, straight off the CAD model, no problem. And Omniverse, RTX rendering, looks beautiful. Could have been done, but there we go. They would spend $200,000. So yeah, I can see the benefits big time.
Yeah, I see a couple of questions in the comment sections, and the questions are around: are we using USD? Are we doing this, integrating this with Teamcenter? And the answer is yes, we are. We want to try and bring this Omniverse integration into Teamcenter. We want to use first of all, we want to do this tight integration between Teamcenter and Omniverse, so that we've got the engineering representation, data managed, lifecycle managed, tied in with what we want to do with Omniverse for visualization. That's kind of what Scott's saying there. We're on the path for that, but that is really going to be the first step in this, because we see there is more benefit for doing this, because we want to bring the visualization in, bring it to life in terms of high quality visualization, but we also want to bring in making those things more live. Can we bring simulation into the world? Can we make these things more interactive? And so this is just the first step in that world of actually bringing in this world. We want to do the visualization, but we want to do these other things as well, bring the generative AI piece underneath with simulation. That's going to be so we're on a bit of a journey here in terms of doing this. This is just the first step. And, to bring that scene together of actually the product, the model, the scenery that it's sitting in, bringing the simulation in, that's kind of where we see USD coming into the mix here. And so, USD is seen as a way to actually aggregate the scene. It doesn't necessarily want to replicate all the data, but it's the way we can actually bring the scene together in a coherent way from all these different data sources, because we also understand that there are going to be data sources that we don't necessarily own. So how do people bring that together into this way, in a way that's open and understandable? So we see USD as the way of bringing the scene on and this aggregation of visual data together in a coherent kind of way. But we also want to bring in simulation. We want to bring in some aspects of, so we can help drive robotics. And also we want to be able to bring in the generative AI piece into that world as well. So really we're seeing this as the first step in our journey of integrating into our portfolio. And also how we want to use USD. So I hope it answered some of those questions I'm seeing on the comments over there as well.
Yeah, no, that's great. And I want to circle back to something you said earlier. So Richard, you saw this firsthand. First of all, amazing job at GTC. But tell me, what was the experience like when you were showing this to the attendees at GTC?
Yeah, I have to say I was biased because it was definitely incredibly impressive. I mean, the crowd was always gathered around the monitor, and there was a lot of oohs and ahs, and it was a real showpiece. I was proud to be part of that because it shows the incredible software that Teamcenter is anyway, that people know. And we had a lot of people that know Siemens, that know Teamcenter, so they were already excited for that. And then to combine it with our technology and see this massive ship, and it's not like it was struggling. That's the thing that people were impressive. It's one thing to pick up the entire ship and all that CAD data and present it. Companies have come to me and said, this is the first time I could ever see my entire model end to end without having to break off engineering, break off structural, break off electrical. It's the whole thing. So, so the fact that they could even pick it up is the goal anyway. But we were running at over 60 frames a second, and it was smooth as silk. And then on top of that was actually one of the, I remember one of the people in the crowd actually said, well, let's see if we can section this. And we actually sectioned it in real time. So it wasn't even just a ship. That's because anybody can run a ship, but the thing is, if you think about a ship, 90% of it is this beautiful big hull, which essentially isn't a lot of geometry. And you could see that a lot of people could fake that, and there's nothing behind that. It's smoke and mirrors. But when we turned on the sectioning tool, you could see every nut and every bolt and every deck and every bulkhead. And again, that's when people really, spilled their cup of tea. It was unbelievable.
Yeah. And it wasn't just the fact that they were looking at the scale of this thing. They were looking at it beautifully rendered as well, right? Materials have been applied to it and so on. And I think there is a question around that, the material application. And just to the point there is that, at the moment, material application is somewhat of a manual process for a lot of things. And what we're trying to do is figure out all sorts of ways of actually being able to apply materials through some sort of logic, whether it's physical materials or a visual bill of materials or something like that, but also then applying generative AI to sort of recognize parts and being able to sort of auto color parts or materialize parts as well. So we are looking at that because we do comprehend the fact that actually making models look beautiful as well. It tends to be a very laborious and costly kind of process. So we're looking at ways of automating that and making it low cost as well. So it is something that we're working on right now and actually trying to get that material through the actual pipeline as well of the digital twin as well.
It was amazing to see in real time. I'm showing a clip from the website so you can kind of see what the scene is in the background. But imagine being able to go inside to every level. Just amazing. Really, really mind blowing. And keep the questions coming. Great comments and questions in the chat. Thank you for joining us, everybody. Whether you're coming on from X or Twitch or YouTube. Let us know if you have any questions for Ian or the team. We'll be happy to address them here. We've got another few minutes with Ian left here. So let me ask you, Ian. So can you talk a little bit about, and earlier in the pre-show, I asked if you had been to headquarters at NVIDIA, and you said, oh, more than me, actually. So can you talk a little bit about the process of how you went about building the solution here? Obviously, OpenUSD was a big part of this, and Omniverse.
Yes, indeed. One of the things we want to do is actually integrate Omniverse, and also we want to get at the Gen AI sort of topics as well. There's a lot of things that NVIDIA has that we want to sort of integrate into our products. But let's just starting with Omniverse. One of the things we saw is we want to integrate that into Siemens accelerators. So, actually NVIDIA has been great and actually very forthcoming in actually helping us. Like what do we need? What requirements did we have? They wanted to find out our requirements. As soon as we sort of expressed interest in doing the integration, NVIDIA has been really helpful in doing that, and actually, working with Sashi and other people and a lot of other people in terms of doing that integration, getting the software, being very easy to get actually copies of the software and actually putting it into our development environment. And then actually, if we run into any kind of issues, we have regular meetings with NVIDIA, sort of at Sashi's level and also product development level, to actually find best practices, ways to do things, even enhancing the product, optimizing the product for us as well. So that's been great. I mean, we've been getting very early copies of the cloud APIs, so we've been working very closely. It's really a co-development kind of effort. And so that close cooperation is something that we really appreciate. That sort of open and honest, open and sort of high integrity kind of joint partnership kind of thing is critical to us. We really appreciate that. So that's the way we like to operate. And so, yeah, it's been very easy sort of relationship at that level to develop this thing. And so really, doing this, and also, they've, opened up the doors to help us to join OpenUSD, the Alliance for OpenUSD, and really want us to actually participate in the Alliance for OpenUSD as well. So we're a member now, and also now looking for us to take on leadership or helping with the leadership of the how do we apply more industrial ideas and practices into the USD format itself as well. And so we're busy engaging at that level as well. So really, NVIDIA has been really helping us to sort of engage with us, but also try to engage at a lot of different levels as well. So it's not just been, oh, here's the software component, come and speak to us on Monday kind of thing. It's been the whole process all through, up and down the stack of actually how to do this. So there's really been, to pick on one particular area is really difficult. It's just been an entire company to company kind of meeting, and actually, joint success is really the sort of order of the day here. It's been a great experience.
That's amazing, and so great to see you on the OpenUSD Alliance. That's fantastic.
Yep.
That the membership list is just growing by the week.
It
seems like. We've got a great question actually in the chat, and this might be really fun to answer. So, what is the most challenging task you're dealing with right now in collaboration with OpenUSD?
I think our biggest challenge in adopting a USD is, we have a lot of different formats today, and also, we have we're an industrial company where data is king, and data has very strict, we say, requirements, in terms of longevity, consistency, stability, and things like that. People, typically, like you in the aerospace industry, data has to be valid for the next 50 years, right? That's part of the FAA requirement. Here we are coming along with USD, which comes in from the media kind of side of the world, which has been super effective in that world, in the sort of media world, and we want to adopt that kind of mechanism. And so we really have to figure out how do we actually take something as effective as USD and its sort of openness and its how it's effective about bringing different types of data together and bring this into the industrial world, and sort of trying to marry these kind of two requirements, or the flexibility of USD with some of the sort of requirements of what industrials need. And so it's really just figuring that out. It's not beyond the wit of man. It's just really just figuring that out and just making sure that everybody's comfortable with what they're doing with USD. What is the role of USD, and making sure people aren't putting things in it that perhaps should not be there, and so on. And so really it's just that making sure that the marriage of that flexibility of USD and the industrial requirements of data are kind of met. But ultimately it's a very open and very flexible format. So really it's just that sort of gaining that knowledge, and industrials adopting knowledge and know-how from another industry, right? And I think another domain And I think that's probably been our biggest challenge, is really more, not so much technical as much as, just more of a cultural adoption of the format, if you like.
That makes sense. That totally makes sense. And, this is also, I think, very relevant. This other question from another user: it seems feasible for companies with existing 3D data. I'm sure you guys see this all the time. How effective is building digital twins for companies without such data?
Yeah, that's a good one. I think this is where we're actually, I think where people don't have existing 3D data, we see a lot of scan data coming in. You see drones flying over and people walking through factories scanning machinery. And so really that whole idea of point cloud and scan information coming into the industrial is taken off. You see a big time, and also converting point cloud and things to more sort of precise geometry elements. But also what it means is, I think we have to take point cloud as perhaps more of a first-class citizen inside industrials, to turn it into 3D and also integrate it into things like USD, I think is really where that is coming from. We see a lot of, specifically in factories, where there just isn't a lot of 3D data or existing 3D data. So people have to run scans and point clouds and things like that. And I think that's kind of the route into that world. So I think that whole world will have to get more integrated into this. So USD is, from my perspective, has to really understand how to do point clouds and very large data sets with point clouds. Yeah,
that's great. Oh, go ahead. Sorry, Richard.
No, saying that, and that's one thing where AI will really help in the future, because the thing is, scanning's been around for a while, but it's always started off as kind of a messy format. It's getting cleaner and cleaner and higher resolution, and a lot of the scan data today has a lot of automation with AI at the back end. So, for instance, like finding the level 4, finding the 0 index of height, turning essentially a rough data set into livable BIM data, doors, windows, floors.
Into
so,
geometry.
In the future, in as we get better, you'll be able to scan entire factories or environments, and rather than just being a bazillion points, it'll be live, searchable, indexable metadata with, this is a robot, this is a door, this is a bolt. And so the difference between scan data and original BIM data is going to diminish to the point where AI can probably convert, scan data into almost fully integrated BIM data. And you'll be able to open up a file and not necessarily know, was it created by a human, or was it created by scan data turned into BIM data by AI? Right. So that's really, once you have that level, the difference between having a CAD model from an engineer and just going out to a shipyard that's 30 years old and scanning it is going to essentially disappear.
Yeah, I agree. And I think that's where a lot of AI, you'll see a lot of AI. How do you take point cloud into geometry and searchable metadata, right? I think that's kind of where people need to go. Marine, plant and energy, all these sort of industries, typically how they operate, because plants and ships are basically built and immediately people start modifying them. So what you have from the CAD and what's actually sitting out in the field are typically quite different sort of things. And so scan data is often probably more accurate in terms of what the reality is than the actual original design.
Scott's laughing about that, because I can tell Scott knows all about that.
That is 100% on the money. 100% on the money. It's like, as soon as you give us it, we break it. So no problem.
I'm always surprised at how much crews on ships actually modify their own ships.
We just like working. That's what it is.
And Ian, I know you have a hard stop in a few minutes. I don't know if you had time, you wanted to share your slides or.
No, I think we've had a great conversation. Okay. I mean, if we have another one of these, I can share some more things around the industrial metaverse if people want more of a definition. I think we can do that. That's great.
Listen, this time that we had with you has flown by.
It's been great.
I just looked at the watch. I'm like, oh my gosh, we're actually running over with your time. So Ian, thank you so much for coming, and thank you so much for being just an amazing company. Please, we're all huge fans of what you're doing. And it was just amazing to show that off and see everybody's really awe on their face when we showed things off at GTC.
Yeah, I think same thing with NVIDIA. It's been great working with you guys. I mean, as at the keynote, it took my breath away. The accelerated computing vision, is just, there is something really spectacular about that. And it's, really, not often you come across something that's that innovative and just like, yeah, that's just that's just amazing. And it's such a fun company to work with as well. That's what's even making more amazing about this whole thing, right?
Yeah, well, thank you. And for those who joined in late, we have been talking with Ian Fisher from Siemens and learning about how Siemens is pioneering the convergence of real and digital worlds by leveraging Omniverse APIs into Teamcenter X. It's been an absolutely pleasure to have you here, Ian. We're going to continue the conversation, and we hope to have you on soon. Anytime you want to come on, you can just let me know. You have an open invite.
This is way more fun than the day job. Yeah. Thank you very much, guys. Thank you.
Thank you.
Take care. Bye.
So that was pretty amazing. So Richard, Scott, and Shashi, obviously we touched on a lot of different points there, and lots of great questions also in the chat from the community. I wanted to touch on a couple things. So first, Shashi, I think it would be great to learn more, because I'm sure there are other companies who are watching this and say, oh, that this is a really great opportunity. How should we get started? How do you approach this when you start working with a company like as great as Siemens?
Yeah. So fundamentally, my first reaction is go download Omniverse and just go kick the tires. Go to the OpenUSD website, start learning about USD. What a lot of folks struggle with is just understanding the technology here. When I first started with Omniverse, actually, I'll tell the story. When I first started with Omniverse, I wasn't working at NVIDIA. I was working at a different company. And we were modeling wildfires. And we were trying to manage wildfires with, our platforms and our sensors and so forth. And I was the chief architect there. And I thought, Omniverse could be the common operating picture for this. It can ingest all of this data, and we can put it in OpenUSD, and then we can use that as a way to aggregate it out and disaggregate it out to all the users. So as we thought about this, we started looking at it from a technology perspective. What makes it so unique? And a lot of the challenges come in with a groupthink mentality or a non-invented mentality of like, well, this is just a file format. And as we dive in deeper, we find that OpenUSD is not, quote, just a file format. It is actually a very revolutionary concept. It's very similar to how Docker has revolutionized the way we would do development and deployment of software. It's the same way that we're looking at it from a data perspective. And so when companies want to start with this, that's where I would suggest they go. Go look at OpenUSD, go pick it up, start looking at the concepts there. And then, happy to engage with them, right? We've got our programs in which incubator programs and so forth, where people can sign in, and then we can get connected and we can start exploring what they're trying to do and help them and enable them.
I was just typing in the chat quickly. I think, it's an amazing point. And I'll just say it instead of typing it to Amelia. Amelia, if you could look for the playlist link for Aaron Luck's OpenUSD series, I think that's a great added link for people to go to if they're just jumping onto the stream and they don't have a good introduction to OpenUSD yet. That's a great playlist. Aaron has done an amazing job covering certain topics into bite-sized chunks. There's also lots of stuff on our YouTube channel, obviously. There you go. There it is. And she'll post that in the chat also. But yeah, I think OpenUSD seems to be the key to unlocking just a lot of things which have been siloed for so long. And it's great that companies like Siemens are there helping companies really leverage this to the max. Because I think it could be very overwhelming for companies to just figure out where to get started and how to start and how to integrate this. And that's where I guess Siemens comes in. So I think it's a very powerful story. And Scott, so when we tell me about when you were at GTC, you obviously were on the floor. We had dinner with strangers, which was great fun. But what did you take away from that from OpenUSD regarding OpenUSD, and what kind of excites you about that?
I think for me, it's really about the collaboration between companies like NVIDIA and Siemens, and then how can we get all that data flowed between itself. So you've got, whether it's visualization or you're running data, you're recording data, to generate AIs for different things. I mean, then you've got large language models and robotics, and there's just so many different fields, and they're coming together at the one time. And it's being able to pass that data between these different companies and having that OpenUSD, so there's like a standardized format that all companies can sort of work to. I mean, that's where the real power works with, because if you look at all these different file formats, you can't get anything to work together, and then you need, programmers to come in, this and that, and it's all expense, and it might be expense that companies don't have. They don't have that spare capital to invest in that, but with OpenUSD, it just lowers that technology bar so far down, and then it means we can integrate all like different companies' data and different types of data. So that's, for me, that's really what I took away. It was just all the different fields coming together around about OpenUSD. So it was really amazing.
Yeah, and I see Nandu is here in the chat. So Nandu, thanks for joining us. So Nandu actually is leading an OpenUSD study group on the Omniverse community Discord server. So if you're interested in learning more about OpenUSD, that is an amazing place to go. He's posting a link right now in the I think it's in the Twitch chat. So maybe my great colleague Amelia can grab that from Twitch and put that for the YouTube viewers as well. There we go. That's going to be a hard link for people to copy, but we'll see if we can get that in the. Well, we'll update the description afterwards. But the great resources there from Nandu, and a big thanks to you from the NVIDIA team for spearheading that study group, which is basically a weekly meeting with community members diving into different areas of OpenUSD. And Shashi, I love that analogy you just gave too, because I think the quick way for I think when you first talk about it with people who never heard about it is to say it's a file format, but it's really not a file format. But your Docker analogy is super interesting to me, and I know that I've heard also OpenUSD being referenced as the like the HTML for the 3D world. What the HTML was for the internet, OpenUSD is for the 3D world and simulation. Obviously, Omniverse is the development platform that you can leverage OpenUSD very easily. And now by leveraging APIs, you can tap into it easier than ever before. So really exciting times. So where do you guys think things are headed next? So I know like one of the most compelling things for me personally at GTC was how many people were super excited upon learning about what's possible with OpenUSD and also with Omniverse. How to get started and just basically I had some companies that approached me and said, wow, I'm here just to learn about digital twins and how digital twins could be leveraged for our company. And what I think there was definitely I sensed there was a little bit of fear there of missing out on not being able to move on it quick enough. I'm curious what you all think about the prospect and the challenge of digital twins for companies, especially who might not have all that data ready, because it probably could be a little intimidating.
I think data. Oh, sorry. Go ahead, Richard.
No, you go ahead.
Well, I was going to say, I think data is always an important thing, but I also think that companies that haven't started with digital twin need to understand what they mean by that, because I don't think there are turnkey solutions. I look at what we're doing with Omniverse as a platform, OpenUSD as a standard, as a means for people to build their digital twins. So if we take another analogy, someone might say, hey, I have this great simulation that tells me and forecasts various things about my process. So great. That simulation may be just a spreadsheet. That simulation may be an Excel document, but what they're referring to is they built a simulation, right? They had to go write the formulas into Excel or into a spreadsheet. They've had to go think through that process. And I find that Omniverse and OpenUSD is similar to that when it comes to digital twins. If you want to build a digital twin for your vehicle, that may be vastly different than a digital twin for your climate. And to do those things, there isn't like a turnkey out there that says, okay, I'm going to download the climate digital twin all of a sudden, and now I am predicting, I don't know, weather phenomena on Jupiter. Like, someone has to do the engineering there.
Yeah, I think I agree with that. And when you build a digital twin, the goal is not to necessarily absolutely simulate all reality. You ask yourself, like a science experiment, what am I trying to extract out of this data set? So for instance, if you're building a building, you may look at like solar tolerance, like how much solar radiation is entering the building or leaving the building, a heat exchange. So you may build this model specifically for that reason, like the climate change model. So not everybody has to approach their digital twin in the same way. It could be a mechanical tolerance of like how a bolt fits into a bolt head. It could be an energy thing. And we're also getting into things like LiDAR and infrared simulations and sensors. Like, how does a robot see? How do you improve the vision of a robot in a dark factory? Or how do you optimize the sensors placement of a robot? We've done a lot of work with robotics, like for Amazon, to drastically improve how their robots see humans and see dangers. And nothing was built necessarily photoreal at that level. It was about structural analysis and sensor placement. So digital twins are different things to different people. But like Sashi said, doesn't matter. It doesn't hurt to have everything photoreal. We offer the opportunity to build your world the way you see fit. And there are other simulation softwares out there, but what we're attempting to do is combine simulation with physics and with a photoreal rendering engine. So you're not limited visually, like Ian said. There are plenty of things out there that shows you two parts moving together, but in a realistic setting, not always.
Right.
And,
Good point.
and Richard, to add to that and probably address some of these questions, the digital twin isn't purpose built; it's purpose used. And so the question is like, well, how did we use a Omniverse or a USD for wildfire, or why would we simulate seas for ships? And the answer is really, what is it that you're trying to attain? So for my wildfire use case, the reason I wanted to visualize this in USD and an Omniverse is for synthetic data training for AI. We have empirical models right now that we utilize that, people went around in the 60s and 70s and watched wildfire and tried to measure the parameters to then create a mathematical formula and simulation for that. And so we were thinking, well, what if we could get realistic data, like first real data, throw that into Omniverse and get photorealistic renderings and photorealistic visualizations, both from a optical perspective and maybe even from an IR perspective. And could we train an AI model to look at wildfire spread? And then maybe we could look at how we do courses of actions for responders on that, and how would they react for that? So that's the not purpose built, but purpose used for that digital twin. When it comes to sea conditions for a ship or any naval watercraft, you may be looking at what is the physical tolerances that might happen here. How will it react with turbulent waters and so forth? And it comes into simulation. And I think we're at the tip of that by having it first digitized, right? Like getting it into USD.
I just wanted to come in there and just kind of going back to the Siemens stuff and the PLCs. I think Siemens has 1/3 of the world's PLCs that runs factories. So that they're already in place, like ready. So a lot of the legacy systems, when we're talking about building digital twins, we were able to extract that data from the real-time PLCs and the state they're in, and then be able to feed that data, using OpenUSD, and able to do visualizations with CAD models. And then you can have the geometry, so whether it's cylinder placement, encoders, pressure sensors, all this kind of stuff, and you can build from existing data. So it's not like starting that you need to, go out and spend all this capex. It's like this could be systems you already have. So I think that's maybe one thing to think about as well for the digital twins. Is the metadata that you already have.
Yeah.
Makes sense. I was just actually noting, so anybody who has any questions in the comments, we still have a few minutes left in the live stream, so feel free to ask if you have anything regarding OpenUSD, Omniverse and the APIs and generative AI. Obviously, we just had an amazing conversation with Ian over from Siemens. And if you missed that, you can watch this afterwards on YouTube. Same link should work. And we'll definitely be sure to have him on again someday. So feel free to post your questions in the Discord, and we'll save them for next time he's on. But let's talk a little bit about generative AI and how this is being leveraged, or what the opportunity there is. And so, Sashi, have you been working with a lot of partners on this already?
Yeah. So generative AI quite a big spectrum, right? first spectrum or the current latest hottest spectrum is Copilot kinds of things. Hey, can we use a Copilot to do certain things? And NVIDIA has and showcase things like ChatUSD. ChatUSD helps developers build USD. Other companies, Siemens included, may be using a generative AI model or large language models or so forth for enabling people to utilize their tools a little bit more efficiently, right? So there's that one aspect of it. The other aspect of generative AI is in some of the things we've been talking about. We're looking at point clouds and trying to convert those into meshes. We may be looking at converting and figuring out material properties, and we can leverage generative AI technologies for those kinds of things. We can also use generative AI to start looking for how do we populate a scene. So we've built a factory maybe, and whether we did that from scanning or whether we did that from CAD designs or whatnot, we built a factory, we built it maybe empty, and we think, okay, let's generate some new assembly line or a part into this. And so that would go off and create some new geometry that we can then play with, and we can start modifying and mutating. So it's quite a bit of spectrum. I think, again, this is another tip of the sphere, or tip of the sphere, yeah, on trying to figure out what we can do and what we'll realize with it.
Yeah, that makes a lot of sense. And so, Scott, on your work with Omniverse, and you've been leveraging Isaac Sim and experimenting a lot, I believe. But do you want to share? I don't know what you can share, because I know some of your stuff.
Well, I think that in general, I think that Isaac Sim is really the place if you want to generate synthetic data. If you don't have the data and you want to train an AI for any kind of robotics, it's like Isaac Sim is the place to do it. I'd been looking for some, I think, maybe about a year. And then I spoke to an AI consultant, and then he gave me a few options. And then I looked at the options, and Isaac Sim was the one that really came out on top. And it's just sort of went from strength to strength. And I think there's going to be a lot more integration and application along the way. This is, I think everybody kind of knows this is still, like early days. And I think the generative AI, I think, is going to be coming into the whole ecosystem a lot more, and how that's going to be integrated, and how things are developed, possibly with agents and whatnot in the future. I think it's a very exciting time, but Isaac Sim's definitely the right place to, if you want to model industrial environments, then I would say that is the place to go, in my opinion.
Makes sense. I just posted a link, so if anyone's not familiar with Isaac Sim, it's in the chat right now, so you can check out the developer webpage for it. The Isaac Sim team and the Isaac Ross team also do alternating office hour live streams every Wednesday at I think it's 8 a.m. Pacific. So I believe there's a Ross live stream scheduled for next Wednesday at 8 a.m. You can check the event calendar; it should be on there. We also post all the upcoming live streams on the Discord server, so be sure to join Discord if you're not already. Okay, so Zia has a good question. I guess, Scott, this would be for you. I'll put it on the screen there.
Yeah, I've seen that. All right, Zia. What kind of synthetic data has been generated? Well, you've got a lot of. There's already a lot of synthetic data generation systems built in. So they have custom writers, but there's like basic writers already built in. So you've got you basically be able to generate RGB. You can do semantic segmentation. There's point cloud data. There's a bunch of other things. I would need to have the list in front of me, but there is a lot of data. You can actually do radar. So there's a lot going on.
But I think you also meant like in terms of the clients that may use it. And again, going back to like Amazon, they have to analyze a lot of packages, and we work with them to generate synthetic representations of packages in various states. They could be damaged, they could be scratched, they could have, you see how they have a big chunk missing out of them and things like that. So it's actually generating viable visual data that looks photorealistic, that we don't have to go out and photograph for real. That's how they would do it before. They would try to train a model with photographs. But we can generate a whole scenarios of damaged package, dirty package, muddy package, And the model starts to learn, oh, this needs to be pulled off the shelf, it's damaged, or this needs to be put back on. And so, obviously, yes, there's layers to we can do infrared, radar, but in terms of applications, it's anything that you need to train a model on that doesn't easily exist. An example would be, let's say you're scanning for tires at safety, like a lot of construction sites. Those tires have to be verified almost every week for safety, because if tires blow on construction vehicles, it's very dangerous. And you can imagine that the way they do it is they inspect them by manual labor. But now, like, they could run through a camera. The model could analyze the tires and look for critical damage, tearing or cracking. And that's the kind of thing where we generate that synthetically, feed it in a model for, say, 6 months. And then that camera system now can have a truck run through the camera system and instantly tell you if those tires are safe or not safe.
Yeah, I think Richard, what you're pointing out is like the challenge in AI, traditional machine learning AI, especially for computer vision, is entropy in data. The example you're using with Amazon is a perfect example. One of the things that we learned was, they have a computer vision system for detecting packages. And at some point, they changed the tape for Christmas season. And their computer vision system didn't do so well. And so by recreating the tape inside of Omniverse and regenerating all of that synthetic data through Isaac Sim and so forth, they can retrain that computer vision model much more efficiently. So I'm using tape as the example, but yes, same thing with the damaged packages and so forth. And that's the computer vision aspect of Isaac Sim, and that was amazing. Another aspect of it that I think someone was asking about reinforcement learning and robotics is Isaac Sim comes with also the capability of an Isaac Gym. So you can actually have an Isaac Gym connected to a reinforcement learning loop in which we're using that as the environment. Then you can do the steps through it and so forth. And so a lot of the robotics applications are going to use the reinforcement learning methods through that gym.
Very cool. And again, in addition to the office hours, we also have a very active channel and Discord server for Isaac Sim, where lots of users, new and veterans, are posting examples and helping each other. There's also, if you run into any trouble, there's a dedicated Isaac Sim support forum area on the Omniverse forums. So feel free to go there as well. Well, this has been really fascinating. We only have another minute or so, so I wanted to see if there's any other last minute kind of revelations that anyone on the panel wanted to share with the community who's watching. Thanks to everyone who tuned in today. Amazing discussion all around, and including with the users on the chat. But any last comments from anybody on today's topic? Let me see. Burning.
Yeah. No, it was very interesting. Anyway, it was very, very, very interesting today, actually. Sorry, Richard.
Yeah, it's just with going back to the Siemens, it's just great to see our technology and their technology combining together to create arguably one of the largest structures, on Earth, and doesn't get much bigger than the ships. So, if we can do it for that, then we could do it for pretty much anything, at least for a while.
Yeah. No, I'm looking forward to it. It's a very bright future between Siemens and NVIDIA, I think. Very bright.
Yeah. Very cool. And I see Amelia, if you're watching, I see Sashi has posted a couple of nice links in the private chat here. If you want to get those on to the community, thank you so much. This has been, again, a fascinating discussion. I want to ask Sashi one more question because it came up from a comment in the chat. So where do you see you've been working with Siemens for a while. Where do you see the future of Siemens going? What's exciting to you?
What's exciting for me is, this whole concept of digital twins. What Siemens is doing right now with Teamcenter is opening the door. It's opening the door for designers to collaborate in a live virtual construction kind of environment. If you're not familiar with LVC, that's a term you should Google up. But live virtual construction is like becoming the thing that most industries want to be able to do, where they can go through and start designing what they want and getting it to the manufacturing floor and then getting a feedback loop in. And so I see the future of Siemens and the future of these technologies enabling that, and so that we can get into a really fast cycle for being able to build out. Once you build out, now you have the next problem, which is, okay, I've got it built out, and we had some of these questions. How do I know if we built it and it's operating well? And that's when you're going to start getting IoT data and sensor data coming back into that same digital twin, that same USD backplaned environment, to start feeding that information in. And so now you can start monitoring what the systems or the things that you've built, how they're behaving. And as you're doing that, that's the next thing you're going to do, is you're going to say, well, it'd be really interesting if I put a new thing into place. If I'm building something new, let me run some simulations and what if scenarios for this with the live data that I have and with the historical built data and so forth, and figure out what this is going to look like next year or 5 years down the road, and start building out capabilities forward. So I kind of see a vast future being created by being able to start with these kinds of digital twins.
That is an amazing way to cap off this this very informative live stream. Thank you, Shashi, so much for joining us today and bringing just a wonderful partner to share this story with the community. I think it's very valuable information all around. Richard, as always, amazing co-host, co-producer. Thanks again for taking over last week while I was on holiday. Fantastic
Anytime.
job. You did fantastic. Now I got to look for another job because I'm not.
No, your job is safe. Don't worry.
Scott Dempsey, I can't tell you how awesome it was to meet you in person at GTC
You
a few
too.
weeks ago.
Yeah,
and to have you come on the stream today and just explore the Siemens adventure with us. Thank you so much and your experience. And let me ask you really quick in the last 30 seconds. I always tell people, like, if you're able to come to GTC live, it is so beneficial.
Yeah.
Because of the ability to be able to network and meet other people. Can you confirm that since you were there?
I can highly confirm that, because I would say that the reason I wanted to go, and I mentioned in the last live stream, was that I wanted to go and meet people, and I met so many interesting people, and I've made so many good contacts and seen so many new and interesting ideas and what's really the cutting edge of the cutting edge. And I think getting to speak to people, and you really get to meet interesting people. I got to meet Jensen, so even better. So that was
a cherry on top. Cherry on top. All right. Well, thank you, everybody. Nice little comment from Zia there. Scott, keep on sailing. When do you go out to sea again? How much time you got?
I don't know. No time soon. Another 6 weeks. I'm on dry land for a while. All
right. Well, enjoy it. And to everybody out there, we'll see you on the next live stream. You can catch us all in Discord or on the forums. Again, thank you everybody who's joining us on the panel, and thank you everybody for watching. We will see you next time.
Thanks.
Cheers.